All right, so now we're going to talk about graphing from what we call the slope-intercept form. Before we enter into what is slope-intercept form, we're going to talk about y-intercept because we haven't talked about intercepts yet. So any intercept is where the graph crosses an axis. The y-intercept is the value at which the graph crosses the y-axis. So written as the point 0, comma, whatever our y value is. So in this example here, we cross the y value or the y-axis at this point right here. So our y-intercept would be, here's 8, there's 10, so that means 9, right? Now this one down here, that's our x-intercept. And unless you are finding when y is 0, we normally don't use the x-intercept. So always remember our y-intercept is on the y-axis. That is the most important piece. So that's a y-intercept. So now we're going to do an example, and I evidently forgot to change the example number when I rearranged slides. So, truly this is example 1, but it is what it is. The line models the temperature on a certain winter day since sunrise. So what is the y-intercept of the line? So the y-intercept is at 4. So that's the y-intercept. Or we could write that as 0, comma 4, right? Because that's the point. Now, what does the y-intercept represent? Well, our temperature, so we would be 4 degrees Celsius, so 4 degrees Celsius at sunrise. Now, how do I know it's at sunrise? Well, because each number after is after sunrise. And so 0 would be at sunrise. So that's how I know. And then it's asking what is the slope? So to find the slope, I'm going to find another point. This is a good point right here. And so we go up 1, 2, 3, 4 boxes, and this is 4, 5, 6, 7, 8. So we went up 4 boxes. The reason I counted is I'm making sure that interval, like we're not counting by 2s or by 5s, but we are indeed counting by 1s, and then same going across the x values, we're counting by 1s. So our slope is 4 over 1. And what does it represent? A 4-degree increase every hour. No. Oh, I very much dislike when it does stuff like that. All right, back up and running. Increase each hour. That's what that represents. All right, so then the next piece we're going to talk about is what is slope-intercept form? Well, if you remember when we were finding slope in the last chapter, we said that slope was m. Well, look, m is back again. So the m is our slope, which if you remember is rise over run from a graph, or y minus y over x minus x, right? So that's our slope, and it's always our coefficient. And then b is our y-intercept. And we always put plus b, but if for some reason b is negative, then we would just change this to minus b. And we'll have a couple of those examples as we go. So y equals mx plus b. I have it really big. Why do I have it really big? Because you need to know it. Know y equals mx plus b. It's going to help you get through all of your high school math. All right, so identify the slope and the y-intercept of the following equations. So we just got to remember y equals mx plus b, where m is slope and b is the y-intercept. That's what we got to remember. So it's mx, so that's my slope. So I just write 3/4 here. And b, now this is where we got to be careful. We got to take the sign with it. So this isn't just 6, it's a -6. My y-intercept is a -6. If they ask for the point and not just the y-intercept, we would write this, 0, -6, and that's our answer. All right, I think we have one more of these. Identify the slope and the y-intercept of the following equation. Again, we're using that y equals mx plus b. B is quick and simple. That's a +20, or if it asks for the point, 0, 20. Now, m is a little more difficult right now. We have the negative, so we can put the negative, but what's, there's no number in front of it. And you may be looking at me, looking at the screen going, Mrs. Cartwright, there's no number in front of it. Well, there is. It's an invisible 1. And so our slope is invisible, is -1. That's our slope. All right, so in the next video, we're going to talk about how we can graph using the slope-intercept form. So I will see you there.